So we start with our next concept, which is about laws of reflection, and it's a sure shot question in any of your class test and exam. Draw a neat level diagram and write the laws of reflection. Draw a neat level diagram and write the laws of reflection. So let's understand what is laws of reflection. Before that, let's take our neat label diagram. So let's take our diagram. Okay. In our diagram, we would be drawing a reflective surface, which is the best, easiest one being a plane mirror. So, and we would also give something known as a legend. Okay. So let this be M and let this be MN. And I put a legend key out here, legend. And I start writing my legend. My MN is a plane mirror. Plane mirror means it is my reflective surface. Have you understood? This is my plane mirror. Now I need to show here an incident ray. So I'm taking green as my incident ray out here. Okay. And I name this as A. I name this point as, say, O. So I write AO is my incident ray. AO is my incident ray. Okay. And since it is incident, I should be showing that it is coming incident on this side. So there's an arrow. O will be known as my point of incidence. Point of incidence. Same thing you'll learn in grade 10 also. Same diagram, same stuff. If you go to grade 10 video, you will see the same thing I'm explaining. Right. Now, from here you need to pay attention. Now, what we will make is something known as the normal at the point of incidence. Okay. So let me make it first. I name this as PQ. My PQ is normal. Normal at point of incidence. Let us understand this first. Okay. Now I'm writing it here. I'll be rubbing this off. The word normal, when we write the word normal in terms of geometry, normal means perpendicular. Shreyas, again perpendicular. Perpendicular means something that makes an angle of 90 degrees. So our normal, which is PQ, our PQ is perpendicular with MN, that is the reflective surface. So if you try to look at my diagram shows PQ in this order, and sorry, my diagram shows MN as the plane mirror, and this is PQ, and this is the point of incidence. This angle is 90 degrees. This is what we are trying to say. Have you understood? Normal where? Now, why did I write the word normal at point of incidence? The normal could have been here, the normal could have been here, the normal could have been here, the normal could have been, but no, the normal is specific. No, it's perpendicular. Yahan bhi perpendicular hi hai. It should be perpendicular at the point of incidence. What I'm trying to mean is that it should be perpendicular at this particular point, the point where the incident ray is coming and striking. It should be perpendicular. See, it can be perpendicular here also, here also, here also, but it has to be perpendicular at the point of incidence. Understood? So that's known as my normal at the point of incidence. In such a case, as we learned in the last class, we're now finding an angle out here, this particular angle, which we write as I. So I will be known as my angle of incidence. I is known as my angle of incidence. Now, children, be very, very careful. There is another catch out here. So if you have understood what is normal, so I'll make this small now, and let me shift this out here. So I understood what is normal. So now let's understand what is angle of incidence. The angle of incidence is equal to angle between incident ray. This is very important from your exam point of view. Incident ray and normal. Now this is very stylish. Incident ray and normal. That means, look at the diagram out here. Since this is a normal, so don't you think that this whole angle should be 90 degree? Yes. And this is I, which means if this angle should be how much? 90 minus I. These are known as complementary angles. When two angles add up to 90 degree, we call them what? Complementary angle. अब exam में आपके साथ कैसे they will play with you, you know? They will not give you this angle. They will mention this as 60 degree, and many children will take that as angle of incidence. Angle of incidence is 30 degree. Sure. It is, yeah, it is the, first understand what is angle of incidence. It is the angle between the incident ray and the normal, not incident ray and the surface. That's how they will cheat with you. And if you are a four-legged animal, starting with the letter D, ending with the letter Y, then you will go with their bait and you will bite it, and then you will solve the problem based on this particular data and bring some big laddus at home and then say, there is some silly mistake. No mistake is silly. You did an idiotic mistake because at that time you could not realize that it was mistake. So it's not silly mistake. Even if I would have given you more time, you would have still done the same. That's GIGO, garbage in, garbage out. Have you understood angle of incidence? Right. So now we make our reflected ray, and our reflected ray will be, I'm showing it with yellow, and it will come out again from this point of incidence, that is O, and it will make an angle of reflection which is R degree. Okay, so then we need to understand what is R. R is my angle of reflection. So let's go and understand what is angle of reflection. The angle of reflection is, करेंगे ना, सर का तो ये दो ही हाथ है बाबा, उसमें से एक हाथ बेकार है, between reflected ray and normal. Again understand, is the angle between the reflected ray and the normal. Okay, I did not draw, so I should name this as OD. So OD is my reflected ray. We should have named this. OD is my reflected ray. Now this is perfectly labeled. The diagram is completely labeled. OD is my reflected ray. And if you are fine, once you finish drawing everything, then we'll start writing what are the laws. Okay, इसको भी थोड़ा छोटा कर दिया. These are also kept out here. Green is very blur. What do I do, sir? Your line is very slow. I can see you. Your cute little handsome face. I can see it very clear. You didn't draw? Acha. The screen is blurred. How can the screen be blurred? Nobody has touched the camera. It's on autofocus, beta. Huh? It might be the internet is slow at your end frame. How am I coming? Can you see the hands moving clearly or blur hands?
They're breaking. Like it's cracking.
Cracking? It should not. I have only one connection. It's working fine.
Okay, now it's working better. Yeah, now it's better.
Yeah. No, that way you can find out. Otherwise, you will see hand. That's the best way to test. As the frame rates go down, then you won't be able to make out. Okay, have you understood this? Are we ready for the loss? So let's look at the diagram. No, you take your time. Mn is a reflective surface. I'm just explaining. Take your time. Mn is a reflective surface, which is a plane mirror in this case. Then we have an incident ray, which is AO. And O is known as the point of incidence. O is known as the point of incidence. The incident ray is coming and striking at O. So at O, what do we make? We first make a normal at the point of incidence. Normal word means perpendicular. When you go to class 10 in mathematics, you'll study tangents and normal. Normal is a line which is perpendicular to a given surface or to a given line. So this is normal. This is perpendicular to this surface. Then we have the reflected ray. So this is the phenomenon of reflection, when incident ray comes and hits a reflective surface and is sent back to the same medium, that is known as reflection. In doing so, the incident ray makes an angle of incidence with the normal. What we should take care is that the angle is the angle between the incident ray and the normal. Similarly, there will be an angle of reflection which the angle reflected ray will be making with the normal. Is these two correct and understood? Do you understand what is point of incidence? Do you understand what is incident ray? Do you understand what is normal? Do you understand what is reflected ray? Do you understand what is angle of incidence and what is angle of reflection? If you have understood this figure, then 80% of the things you have understood correctly. Shall we now write the laws of reflection slowly? Okay, Ikaks, take your time, no issues. Yeah, take your time. No, not pain here. Pain, there's some little bit of mild pain here. Means I won't allow you to like do a handshake or touch this hand now. This area, because so much of fluid has gone, these arteries still have swelling. This artery has pain. The pain is here. There's a line, na? That's there was 1 prick, 2 prick, then 3rd prick here, 4th prick here. In 1 month, so many pricks. Okay, shall we go ahead?
Yes, sir.
Okay, so the first law of reflection says, and you need to remember it, this will be useful till class 12, okay? The angle of incidence is equal to the angle of reflection. Very easy. This is the first law of reflection, that the angle of incidence, that is I, should always be mathematically equal to R in terms of their degrees. Angle of incidence is always equal to the angle of reflection. This is a law, children. Remember that. A law is a law. It has to be obeyed every time. Law cannot change. But you will, after some time, question me on this statement itself. देखते जाओ और कितना मजा होता है. Angle of incidence is equal to the angle of reflection. Children memorize the two laws, in which the second law they don't actually understand. The first one is mathematical, the second one is a statement. And I will bet there will be many children in grade 10 who still will be writing it correctly. But if you ask them, what does this mean? ये क्या समझाता है? They'll not be able to say. So let's understand the second one more correctly. The second one says the incident ray the reflected ray, the incident ray, the reflected ray, and the normal, at the point of incidence. कुछ भी बोल सकता है. Hey, you are remembering wrong. All lie on the same plane. हाँ तो सेम हुआ क्या? You said meeting है. Same word नहीं है. All lie on the same plane. Now I'll explain you. Lie. This is the word lie. Yeah? Lie means words that spell same and mean different. This is not lie and truth. This lie means they lie. Write it down, then we'll understand what is same plane. The incident ray, the reflected ray, and the normal at the point of incidence all lie at the same plane. So the question you get is, state the laws of reflection and draw a neat label diagram. So you should be able to draw a nice diagram. And don't ever write on diagrams, incident ray. At least if I am a teacher, I straight away give 0. Diagrams are to be in diagrams, legends are to be. If it's a biology diagram, then it will be arrowed, and every arrow should be parallel, and all naming should be in one side. That's how we have been taught. You've seen my copies. So I can't expect that child writing with any sort of a pen. Our teachers didn't make us do, and I cannot. Well, you can say, sir, in my school we get full marks. Yeah, that you'll get. In many roadside places, we get, yes, sir, how much more you want idli? Rendu idli, rendu idli, like that they will give you. You can eat it. Doesn't mean that you will fall sick if your immune system is good. But I always love to have it. That's idlis for you. Sophisticated. Have you understood this? So let's understand what is lying on the same plane. Okay. So for that, we need to first understand what do we mean by the word called plane. So at your level, to best understand a plane is like a Xerox or a A4 paper, right? And you take a A4 paper and you put it in any orientation in space. Every orientation is one plane. So let me say this mobile phone of mine. This is a plane in space. This is a plane. These are the two easiest plane. Horizontal plane, vertical plane. There can be an inclined plane. There's this. So how many planes are possible? Infinite number of planes are possible. Have you understood? Now, you have to be a little bit, you have to take it like a 3D. Though I can't draw 3D, I'll try my level best. Okay. So let's assume that this is a sort of a plane. This is a sort of a plane. Have you understood? Now, say suppose I have got two lines. Okay. These are my two lines. Two lines in any orientation can always be in one plane. How to test it? Take two lines, any orientation. You don't agree to this angle? Let's make it like this. You can always put a textbook behind them. So two lines are always on the same plane. Sir, you make it like this. No issues. A textbook can still come and contain both of them. Do you agree? And when these two lines are on the same plane, what do we call these two lines? Coplanar. Have you understood the word? When two lines are on the same plane, so what I'm trying to do here is, say suppose I've got two line segments out here. I have got a yellow line segment and I have got a red line segment. Okay. Now these two line segments are called coplanar. Have you understood the thing? So I call them what? Coplanar. Coplanar. That is, they lie on the same plane. So if I ask you a question, are two lines coplanar in any orientation in space? Yes, they will always be. Now let's take three lines. And the best way to understand is the tripod camera stand. Let's take the tripod. You know the tripod of a camera? Can you have one book which contains all the three arms? No, not possible. Not possible. That means in three lines, we have to be very, very specific. But if we go and see the weapon that is in the hand of Goddess Durga, or the fork, or Lord Shiva, that Trishul, the three fangs are coplanar. Are you understanding? I can take three books and I can put them in one plane. Now do you understand? In three lines, the coplanar concept becomes a little bit conditional. Because in every orientation, you can, suppose I give you my three fingers in this manner, can you make it coplanar? No, only two at a time can be coplanar. Three cannot be coplanar. But if you go back to your diagram, you are dealing with three rays out here. Now see what you have written. You have written the incident ray, the normal, and the reflected ray. So means you're going back to the Trishul concept. And you are saying that they are coplanar. So let's understand what do we mean by that. Okay, so let me draw one more plane. And I'm guaranteeing you, you go and ask any grade 10 child also, they will say, this is something we write, but they won't be able to explain you what does coplanar mean. So let's say this is one plane. Have you understood? This is a plane. Now on this plane, what I do, I take a reflective surface. Now this is 3D. So keep your eyes fed. Say this is my 3D, that particular mirror is this one. Have you understood? Now, my plane, where is my plane gone? Yes. So I am now taking a small plane on it. Okay.
Sir,
Yes, sir.
my battery is running low, so I might leave soon.
Okay, your wish. Okay, now try to understand. The red one that I have drawn is basically this tabletop. Do you get it? The red one is the tabletop, right? On this tabletop, I have a reflective surface, the white one, which is kept like this, the white one, reflective surface. And now I have drawn a green plane on it, which is on the reflective surface in any orientation. Have you understood? Now what we try to say here is that when it is on the same plane means this is the orientation of the the reflected ray, the normal, and this are always on this plane. Have you understood? It is like this. Let's say these are my three rays: incident ray, normal, and reflected ray. This is a plane. Now they may come, and this is my reflective surface. This is my incident normal. Whenever they come in one plane. They can come and get reflected like this, means coming here and going there. They may come like this, they may come like this, they may come like this. They come in one plane. It's not that only one green plane. There can be many such green planes. But it is never possible that the incident ray is coming like this, the normal is like this, and the reflected ray is like this. Have you understood? So what we try to explain here is, say suppose this is my incident ray, then I need to have a normal at the surface, and say this is my normal, and then I need to have a reflected ray. Say for example my reflected ray is violet or purple. So say that's purple. So this is what we are trying to explain when we say this line: the incident ray, the reflected ray, and the normal, whenever they are forming at a point of incidence, they are forming in a coplanar manner. Are you understanding? That means at this point of incidence, I can take many A4 pages and align them. One A4 page, how can my A4 pages get aligned? One page may be like this, one may be at 30 degree, one may be at 60 degree, one like that. Any different way. The only condition is the rays are always coplanar. Have you understood? Will you be able to explain anyone when somebody tells you what do you mean by the second law of reflection? The second law of reflection says that if the incident ray is along this panel, smart panel, the normal is also along the smart panel, and so is it cannot be that the incident ray is on the smart panel on the brand name, and the normal is coming from here, and the reflected ray is going this way. Then you cannot keep them in one plane. It has to be in one plane. I think I have been able to explain you. Should you still feel that there is some difficulty, this is just for the understanding purpose as to what we mean by angles on the same plane. Now, if you could have taken the green one and made it like this, I don't mind. Then the rays will always be on that. Because it's not that only one ray. See, this all things, as I told you, these are all imaginary to support geometry. How do you know only one ray is coming? Millions of rays are coming at million different orientation. So how many planes of reflection are happening? Infinite. For our simplicity, we have understood with only 3 rays. Have you understood? So that's, you can write it now. If you have understood, very good. You can write these 2 statements, and this is a sure shot question in any of your examination. What do you understand by, or define reflection and state the laws of reflection, or state the laws of reflection and draw a neat label diagram and explain them. Okay? When you will be in your school and all, the second part, they will just all lie on the same plane. Everyone knows it as a memory. Uska matlab kya hai? It means that the 3 rays cannot be like the legs of a tripod. The 3 rays have to be like that of a trishul. That is the only orientation that you can have. Like a fork. Then only you are on the, but the fork does not have one common point of incidence. You have to have a common point of incidence. Have you understood? Okay. So any doubt on reflection, laws of reflection? Yes, please. All okay? No man. If you want to remember, you can ask. Can I proceed to our next topic? Okay. 2 laws of reflection, and when you go to grade 10, then you will learn 2 laws of refraction also. When you study refraction, then also you get 2 laws. So in the water and all, yeah. Yes, any doubt?
Yes.
No, there are only 2 laws. They can write 5 laws, that doesn't matter. These 2 should be there. If these 2 are not there, you get a 0. Simple as that. If I am your teacher. Right? Shall we go to the next topic? Okay. So let's take our next topic. Have you understood this diagram? Coplanar. Are 3 lines coplanar? Depends. Are 2 lines coplanar? Always. Can 3 lines be coplanar? Depends. How is the orientation? After 2, it all depends. Okay. So let's go to the next topic. Our next topic is to understand the difference between something called regular reflection and diffuse reflection. Now, this will be very interesting. Okay. We're going to understand a difference between two terms. One is known as regular reflection. No, not like that. I'll tell you. Let's discuss. Not exactly. Oh, see, what did I write? I spoke in between and I lost my concentration. No, not an issue. Regular reflection, and we will understand along with it something known as diffused reflection. Okay. I hope I'm audible, right? I might be speaking a little bit slow today. Diffused reflection, right? So let's see what is a regular reflection. Again, diagram and drawing will be there. So let's draw a reflective surface, which is a plane mirror. Children, in science, biology and all, the more you draw, the more you learn. So you should be very good in your diagrams and you should be fast and swift. Okay. So this is a plane mirror, right? And this time what we are having is, unlike one incident ray, we will have a beam of incident ray. Now, what is a beam? A beam is a collection of parallel rays. So we have a beam of incident rays. Understood? So we can again name them. Let's say Mn is our mirror, and we have A1, O1 as the first incident ray, A2, O2 as the second incident ray, and A3, O3 as the third incident ray. Mind you, they are all rays of a beam, so they are parallel incident rays. Okay, as of now, I'm not writing anything so that you can understand the diagram and you can correlate. What did we draw? We drew a reflective surface, and on that reflective surface, we have bombed a parallel beam of rays. Okay, and we have shown 3 rays. We could have shown more than 3 rays also. So the 3 rays are A1. So we have got 3 points of incidence now: O1, O2, O3. So if you have 3 points of incidence, then 3 normals should also be bombed. Why? How can you take them away? So let's take those 3 normals and make them right on the 3 points of incidence. And see, you need not look at my diagram. You have understood what to do, because you are trying to just formulate the reflection phenomenon. So my diagrams are all arbitrary, so my lines are not getting straight. Okay, somehow. By that time, you will be faster than me. Okay, 1, I could succeed. And then 2, I have succeeded. And I have succeeded. So there are 3 normals, and we named our normals as PQ. So on this, Pepper says it's going to be P1, Q1. Daddy Pig, this would be P2 followed by a Q2. And on this, we have a P3. And on this, a Q3. Today, Peppa and his friends are learning what is about regular reflection. They have a small reflective surface on which 3 incident rays have come and impinged upon, making 3 points of incidence as O1, O2, O3. Right? That is Rebecca Rabbit, Susie Sheep, and Danny Dog, and you have 3 normals being drawn on that. And after that, what do? 3 reflected rays. Okay, so let's make our 3 reflected rays. Mind you, the angle of incidence for each case should be equal to the angle of reflection. So let's put some angle of incidence, I1. We have an I2, and we have an I3. That's how the Brits speak. We got an I1, an I2, and an I3. And if he's Australian, he will speak, I got 3 incident angles. You know, you get an I1, you get an I2, and we have an I3. Looking damn smart, holding right out there. What's that? All nonsense things happening due to stress? You, man, that boy does that. They have 3 angles of reflection now. 3 reflected rays. So take your red lines, markers, children. And we're going to have 1 reflected ray. And Americans will speak nasal, so we're going to have 1 reflected ray. We're going to have the second one pointing out. You have the third one pointing out right from there. You're going to name them all in the orders So the order would be O1. That makes it B1. That's B2. And that's B3. Yes, you understood. This is from Russia. We have made this drawing. Yes. This is from Russia. Vladimir, you got it right this time. Yes, he is my new friend, Techkolova. And she is Mishka, already Russian. Mishka is a Russian name, Mishkalova. And that should be B3. B3.
Spectacular.
Spectacular ray, reflected ray,
You said.
extrapolated. What are you trying to say? These are reflected rays. This is the same one. See, we drew it for 1. Now we are doing it for 3. Have you understood? Clear? Okay. So the formation is correct. So we write, this is regular reflection. So how do you now put it in English? Do you now put this thing in English? How do you put it in English? If a parallel beam of rays upon being incident on a reflective surface is reflected parallelly, right? Then that reflection is known as regular reflection. Okay, so in this case, what will happen is that A1O1 is parallel to A2O2, and this is further parallel to A3O3. This means the 3 incident rays which came, they came parallelly. And they are also reflected back parallelly. That means we have O1B1 is parallel to O2B2 is parallel to O3B3. This is the guiding principle for regular reflection. In regular reflection, a parallel beam of incident ray is reflected back parallelly. So let's put that into words and test your English, because you guys only speak in English. You're bro, you're crow. So see, let's how you start English. If a beam of parallel rays on being incident on a reflective surface is reflected back as a beam of parallel reflected rays, then such a reflection is called regular reflection. Okay, so regular reflection means if a beam of parallel incident ray after reflection is also reflected back parallelly. No, you don't need to look at that. Have you understood this? The diagram and the process. Have you? I'm not that I'll not tell you what it is. Have you understood the diagram and the concept? Now tell me, there's nothing patient. Look at me, look at me. Have you understood the diagram and the concept? Have you tell me what did you understand as regular reflection? I'll tell you what that word is. Let's understand. We have a reflective surface. A beam of parallel rays are coming and getting incident on it. And what is happening? They're being reflected back parallelly. If such thing happens, it's regular reflection. Put your English and write that. I don't mind whether you use my words or you mince my words, use your words. I don't mind that. The only condition is what? 3 conditions. Reflective surface, parallel incident rays. That's where, see student, science is all about understanding. Reflective surface, parallel incident rays, parallel reflect. 3 criteria you meet in your definition, and your definition is right. You need not copy my words. If you're copying my words, I will write here Rama defeated Ravana in regular reflection. You will write that also. But then you're writing garbage, right? You are supposed to understand science. So what are the 3 things needed? A reflective surface, then a beam of parallel incident rays, and what is the condition? It should be reflected back parallelly. Bas, ho gaya. Now you put it, when a beam of parallel incident rays is reflected back parallelly, then the reflection that occurs is known as regular reflection, full marks. If on a reflective surface, a beam of incident rays after being reflected have been found to be parallel to each other as reflected rays, then it is a full marks. Who says you have to copy my words? No. You write your words and then I would be very happy if you cross-check your definition with me. Sir, I wrote it like this. Am I correct? That is learning. हमारा line में जाना है. You do not be my disciple. You will frame your sentence and then cross-check. 3 conditions, remember. Or else you can write like this. For regular reflection to occur, 3 criteria must be met. A reflective surface, point 1. 2. A parallel beam of incident rays. 3. The beam of incident rays should be reflected back parallelly. Full marks. यही तो पूछा था. When was Quit India movement? 1942. 1942, correct. 1942, correct. Need not be that you have to write the way I write. See? Now see the challenge to frame words. That's what was not done in your schools from when you started your middle school. We feel we are good in English. We are not good in English. If we were good in English, we should see the story and we should be able to frame it. First, we will frame it in many words. Then we will be able to concise it. Then we will be able to better concise it. Then we will see this is the minimum. We can't go beyond that. That is called an optimum answer. Tell me something about it. And sir, actually, I'm from Hyderabad, and basically my mother tongue is Telugu. So actually, what actually, dochually you're studying? Be transferred. Yes, my name is Mishka and I'm an 8th grade student. I am studying here. That's it. If the man probes more, because this is an open-ended question, tell us something about yourself. I have so many things to say. What do you want to hear? You tell me. What is your date of birth? Narrow scope, closed-ended question. One response. My date of birth is blah, blah. Actually, when the moon was lit very nice in the year of this thing, the cold breeze was blowing, and at that time on this planet, the population increased by 1. That's when I was born. Right. Got it? Oh yeah, shall we go ahead? Diffuse reflection. So let's understand diffuse reflection. Now, diffuse reflection is interesting. Okay? So let's first draw what is happening in diffuse reflection. So obviously we will have a reflective surface. Everything will be same as the first one. That's my reflective surface and I etch it. So that's my reflective surface. Now I'm going to have again a parallel beam of incident rays. So by now you have understood. In this case, what will happen? They will not be reflected parallelly. Right? Wahi karna hai. Because that word. Because you first finish this. Acha, done. So let's take again 3 parallel rays. 3 little rays who are parallel like children. They've come across here. So I named them as I1, O1, and an I2 and an O2. We have an I3 and an O3. All we need to make is 3 normals out here. So let's make those 3 normals. And don't get abnormally wrong in making those. So, no, yes, we love the way the Brits speak, So these are my 3 normals. And let's name them. That's P1Q1. That's P2Q2. And that's P3Q3. Are we done with this, children? Yeah? However, you have a freedom now to make your parallel rays. Just make sure that they're not parallel to each other. Draw them in any orientation that you feel like. But don't be too much of a, don't make your drawing too looking stupid. Okay, one ray I've made this way. The second ray I've made this way. The third ray I have made it this way. So let me put my direction arrows so that they give you a little bit of an idea of what these rays are. I forgot to put them on this one. So here it is. And that's one, that's another one, and that's another one. I'm going to name them also. O1B1, O1B2, and O1B3. Now, just see what's happening out here. I got 3 rays which are incident and they're parallel. The reflected rays are not parallel. Clear? So can you frame it now on your own? That if a beam of parallel incident rays, don't look at the book. Why are you looking at the book? Books are looked by cowards. We are not cowards. We need to understand. if a beam of parallel incident ray is reflected as non-parallel reflected rays, then such a reflection is known as diffuse reflection, right? So the criteria here I will have here is A1O1 is parallel to A2O2 is parallel to A3O3, but O1B1, sorry, O1B1 is not parallel to O2B2, is not parallel to O3B3. Now this is the criteria that's happening in diffuse reflection. This is what needs to be met. So you can write your own sentence now. If a beam of parallel incident ray is reflected in a non-parallel manner by a reflective surface, then the reflection is known as diffuse reflection. Okay, we'll say a parallel beam of incident rays is reflected as non-parallel reflected rays. And such a reflection is known as diffuse reflection. Are you getting it or not? Now understood? Good.
And such?
And such, right?
No, sir, I forgot it.
No, you did not forget it. That means you are tailgating me. I did not say anything. I was rather saying that when Rajnikant was acting in a movie and reflection took place. You write your own words. Take your own understanding and try to get it. So three criteria here: reflective surface, parallel incident rays, and non-parallel. How that we will see now. Now we'll see how.
The plane.
No, you should now ask me that in these criteria is the angle of incidence not equal to the angle of reflection, because otherwise you're just copying, you're not paying attention. See, the angle of incidence is always equal to angle of reflection. Now just look at this particular diagram. Is it satisfied here? Yes. Is it satisfied here? You'll say no. But then my question is, those were the laws of reflection, and laws will always be obeyed. So what is going wrong out here? Apparently, this is the beauty of science. Apparently, what do we feel? We feel as if the angle of incidence is not equal to the angle of, but that is a law. It's a law. A law is a law. You cannot disobey the law. That means something is happening out here which we are yet to understand. We should not attack it from the law per se. Law is never followed. So shall we see what is happening out here? So to do that quickly, I can't copy that diagram because that was wrong. So let's try and understand. Okay, so let's try and understand what is happening in diffuse reflection. So this is my reflective surface, and I'm drawing it very quickly now. I won't label it. So I have got three incident rays. And I've got three normals. You can draw it at your same diagram. You need not draw it again. Normal 1, normal 2, and normal 3. And I've got three reflected rays. Say one is this way, one is something like this, one is something like this. Have you understood? Right? This is what was happening. So for better understanding, this was my incident rays, and these are my reflected rays. Okay. Now, in order to understand what is happening out here, what we will do is that we will take a small portion of this surface. Okay, take a small portion of this surface, and we'll try to magnify and try to understand what is happening here. We'll try to see a small portion, right? When regular reflection was taking place, it was taking place from a polished surface. This happens when the surface is not polished, or we would say, all right, you are finding, okay, before going here to this, The diffuse reflection also has another word, and in place of diffuse, the other word sometimes we use in books and textbooks are, we'll be using a word called, say, irregular. That's for us to understand. Irregular. Okay, irregular. So let's go back and look at this surface. So this surface, which you are thinking that the surface is very smooth, this surface isn't smooth. Now, a lot of findings we will see. If we see it magnified, then the surface is not smooth, but the surface has, are irregular. I've heard you, bhai. Irregular. Hold on. Irregular. So it has a lot of undulations like this. Now, this is a magnified impression of that surface that you are trying to see. Have you understood? Each small undulation is behaving as a reflective surface. So it's something like this, that the rays which are coming, they're definitely coming in a parallel fashion. There's no doubt about it. Okay, the incident rays are coming parallelly. So they have come. I've tried to draw, say, 3 parallel rays. These are my 3 parallel rays, and they are coming parallel. And each of them will be obeying laws of reflection. There is no doubt about that. As I said, a law is a law. So normal is always normal to the surface. Right? Let's see the next normal. The next normal would be like this. They are normal to the white surface. The third normal would be normal like this. Have you understood? Now you apply law of reflection. What is the law of reflection? That the angle of incidence is always equal to the angle of reflection. Now see, the green beams rays were actually parallel, but if you see the yellow ones, they are all following the law of reflection. See the beauty. Have you understood this? So what is happening here? The surface which you are apparently thinking that it is smooth, the surface is not that smooth at all. It's an irregular. So diffuse reflection always happens from irregular or uneven. Every day your pen cap falls. Every day. Uneven surfaces. Children, sometimes come here and try to teach with so much of distraction. Will you be able to teach? Uneven surfaces. These are so interesting things, and I bet if you're in your book, you will not understand. Neither, I don't know how much it is done in your school. I don't think so much of diagrams are drawn in any school. Nobody will draw. They'll show you one PPT and make you mug up and go. Here you're getting the chance to discuss, to argue, to understand. Then you fiddle with your pen caps and all. So have you understood? Now the question arises that if I find regular reflection versus diffuse reflection, okay? Regular reflection versus diffuse reflection. And I asked a question to myself that, considering me as a human being, which one would you prefer? Which one would you prefer? Tell me. Regular. If you prefer regular, then your answer is wrong. You know what is regular reflection? That means the whole world around you is like a mirror. Everything is reflecting properly. A mirror is a best example of regular reflection. Have you sometimes gone to something like a Bajaj Electronics or to a store where there's so many televisions? Let all televisions be switched off. Then as you walk, you see so many Abhigyas walking along with you. Do you want the world to be like that? Yeah, the world is all become like a mirror. Everything is having regular reflection. It's like you're in a mirror room. Today, we don't want that. We want diffuse reflection. That's the reason you're able to write. Do you see your face? No. Now, the question arises, this table from optics, the surface is not polished. But I see that this is very polished even. But there are undulations. That's why when you observe it microscopically, there are huge undulations, granular undulations. That's why regular reflection is not taking place from here. Otherwise, imagine Shears. After bath, he has come out. He sees so many Shearses walking along with him. The whole world has become one Shears with towel. There are 1,000 Shearses walking along with him. Like Ravan, you feel. Is that possible? No. So, in a daily life, what is important, children? In a daily life, the thing that is important is diffuse reflection. Imagine you are in like the other day, I was in that hospital. So the view outside the hospital is very good, beautiful views. Now I thought that I should click some pictures also. All skyscraper buildings are outside, but I'm clicking the picture from what? Inside the room, and I'm having a glass door. So will the picture come beautiful? No. The first thing that comes on the picture is another Jainib that's clicking the picture. That's a classic case of regular reflection. My life becomes very horrible. So sometimes we want to click that picture. We don't want the glass to come in between. So in our daily life, that's why I drew this. The diffused reflection is what is we want. Otherwise, the whole world around you will behave like a mirror. Everywhere there is like Snow White and the Seven Little Dwarfs. Mirror, mirror on the wall, who is the fairest of all? So it will become like that. So tell me, have you understood what is regular reflection? Regular reflection, when a beam of light is, regular reflections will always be supported by extreme polished surfaces, or smooth, as you can say the word, good. Polished, or we can say smooth surfaces. And that's why the best example would be a plane mirror. However, is this table not reflecting? Yes. Otherwise, if it doesn't reflect, I should not be able to see the table, right? Very good. I'm able to see the table because rays from the table are also coming back to my eyes. However, we do not find that a ray of light which is coming here parallelly, or beam of light, is getting reflected parallelly. If that would have been the case, then it would have been my glass dining table. And on the glass dining table, let's start doing something with a table lamp on. Super idiots. Table lamp on, glass dining table. As you put your head down, another abhigya will be, what are you doing? And then as you write, another hand will be coming. Life is very moronic, to be using the word. Have you understood? Can you also explain why, what? So sometimes we may ask you a question and we may say, are the laws of reflection not obeyed in diffuse reflection? The laws of reflection are laws. They will be obeyed everywhere. What you are not understanding is that you are carried down by this surface. The surface is not that smooth as it appears to be. Chess. The surface is not that smooth that it appears to be. The surface has a lot of undulations on it. And when you see those undulations, you will always find that the rays which are coming as parallel are obeying the laws of reflection, but the output is not a parallel beam. Such a case is known as diffused or irregular reflection, and that's what we want in order to have our daily days of activities happen in a smooth way. Otherwise, we would not have been able to write. The moment you start writing on it, it's like writing on tracing paper. You'll see your own face. Okay? So, aaj yahan rakhenge. We won't go beyond this. So, in our next class, but every time you come to the class, don't come absent-minded. This chapter is a long chapter in grade 8. So, please read the previous sections and then come. You will have human eye and many other things also. Okay?